Alright, hey guys. First thing we're going to do today is I'm going to teach you how to find the volume of a solid bound by these two functions around the y-axis. So, first we need to identify our equations, or our functions, which would be these two, and we're going to take it around the y-axis. So, we need to sketch out approximately what that's going to look like. Coordinates plane, y equals 2x, and y equals x squared. So, we're finding this area. How do we start doing that? We have to set our equations in terms of x. So, now they're going to become x equals the square root of y, and x equals 1/2 y. Now we have to set these equal to each other to find the intersects. Root y equals 1/2 y. We're going to square both sides. We get y equals 1/4 y squared. Bring that over. Take out a y. So what can our y's be to get them to equal to 0? They can be, this one can become a 0, and this one can become 4. So those are our intersects. What do we do using them? We're going to use them in setting up our integral between these 2 points. So it's going to become pi times the integral between 0 and 4 of our right equation, which is going to be our root y, and our minus our left equation, and these are squared by the way, left equation 1/2 y. So root y squared minus 1/2 y squared, and don't forget your notation, dy. That's going to become pi times the integral between 0 and 4 of y minus 1/4 y squared. Now we can take our integral. So this is going to become pi times 1/2 y squared minus 1/12 y cubed. Don't need c since we're finding the definite integral, and that's going to be evaluated between 0 and 4 again. Alright, so now to evaluate, we just plug in the numbers, the top number plugged in minus the bottom number plugged in. So we're going to have pi times 1/2 times 4 squared minus 1/12 times 4 cubed minus pi times, and these two terms are both going to cancel out, or 0 out because they're 0. So now we're going to be left with pi times 8 minus 64 over 12 and that's going to simplify down, and we're going to get 8 pi over 3, and that's a units cubed, and congratulations, we solved for the area between, or bound by, these two functions around the y-axis.